Right. Unit 2, Day 9. This is test review. Okay, so it says solve the following inequalities, show work, write solutions in interval notation, graph the solutions on a number line. So some of these are equations also. So this first one, the absolute value of x is greater than 8. So remember, when your absolute value is alone, okay, you rewrite it once exact and once with the opposite inequality and negative after. Okay, so knowing that, we're done because it's already at x. X is already alone, so we're going to graph it. So we have negative 8 and 8. So it says x is greater than 8 and x is less than negative 8. Both are not equal to, so it's parentheses. Now, I want you to realize this is a greater symbol, so this is an or problem. So knowing that, it is totally okay that they don't touch, and we're shading everything. So it goes to the left forever, which is negative infinity, and to the right forever. So remember, we read it left to right when we write it in interval notation. So the farthest left it goes is negative infinity. You can't touch that, so it's a parentheses, and it stops at negative 8, and it doesn't touch, so it's a parentheses again. Or it picks back up at 8, and it goes all the way to infinity. Okay, now this one, remember, when your absolute value is alone, we write it exact, and then we write it opposite inequality, negative after. So this is less than, so it's an and situation. So x is less than 8, and x is greater than negative 8. Okay, so this is an and, which means the solution is where they overlap. Well, they overlap between negative 8 and 8, and they have parentheses on the end. So from negative 8 to 8. Now, I want you to realize this is not part of your solution, this is not part of your solution, because it's and it's only where they overlap. Okay? Now here, our absolute value is alone, so we're going to write it exact. It's an equation, so remember, you just write it opposite. Okay, well, there's your two answers, negative 8, comma 8. Okay, if I'm moving a little fast, that's fine. Just pause where needed. Okay, so this one, my absolute value is already alone, but it equals a negative. Anytime, or not equals, it's inequality a negative, but I want you to realize anytime you have a negative, you stop. Okay, so I want you to remember that absolute values always give you a positive number, and positive numbers are less, it says positive number is less than or equal to negative 6. Well, a positive number is never less than a negative, therefore this is no solution. Okay, here our absolute value is alone, so we're going to write it exact. And then we're going to write it opposite inequality, negative after. And we need to figure out if this is or and. So this is less than, so it's an and situation. So knowing that, now we need to solve. So I'm going to multiply both sides by 6, and I get 3x plus 4 is less than 18. Minus 4 minus 4. Get 3x is less than 14. Divide by 3, divide by 3. X is less than, that doesn't simplify, so it's just 14 over 3. Yeah. Okay, then we have this one, so we're going to multiply both sides by 6. We get 3x plus 4 is greater than negative 18. Minus 4 minus 4. 3x is greater than 18, 19, 20, 22, negative 22. Divide by 3, divide by 3. Okay, again, it does not simplify, so x is greater than negative 22 over 3. So we need to graph it. This is an and problem. My negative, ooh, sorry, I'm like turning it sideways. My negative is smaller. Okay, so knowing this, I have x is less than 14 over 3. It's not equal to. Then I have x is greater than negative 22 over 3 and not equal to. And this is an and problem. So my solution is where they overlap. And they both had parentheses. So negative 22 over 3 to 14 over 3. Okay, this is not part of my solution, not part of my solution. Okay, so this is an equation. So y'all, I want you to realize you can simplify this before you keep going. So let's go ahead and simplify it before we separate. Or let's just separate. So we were going to write it exact. And then we're going to write it equal to the opposite. Okay, and then we're going to solve. Okay, the reason we got to just go ahead and break it apart is because the absolute value is already by itself. So here we're going to distribute, and we get 10 plus 6x minus 3 equals 1. Well, 10 and negative 3 are like terms, so we get 6x, 10 minus 3 is 7. Minus 7, I get 6x equals negative 6. Divide by 6, divide by, ooh, that's a 6. X equals negative 1. Okay, so same thing on this side. I get 10 plus 6x minus 3 equals negative 1. So 6x, because these are like terms, plus 7 equals negative 1. Minus 7, 6x equals negative 8. Divided by 6, divide by 6. I get x equals, split them in half, I get negative 4 over 3. So this is an equation, no inequality, so I just put them in. So negative 4 over 3 is smaller than negative 1. Okay, this next one, again, my absolute value is already alone. So I'm going to go ahead and write them out. So my first one is exact. My second one is opposite inequality, negative after. And I want you to realize this is less than. So it's an and situation. Okay, so knowing that, let's solve. So I'm going to subtract 3, and I get negative 7x is less than 1. Divide by a negative 7, divide by negative 7. Well, when we divide by a negative, we flip our symbol. So that gives me negative 1 over 7. So minus 3, negative 7x is greater than negative 7. Divide by negative 7, divide by negative 7. We divided by a negative, so we're going to flip our symbol. We have to get positive 1. So we have negative 1/7 and 1. So x is greater than negative 1/7. It's not equal to. X is less than 1. Not equal to. And remember, this is an and situation, so it's where they overlap. So it's from negative 1/7 to 1. Okay. So here, again, our absolute value is already alone. So we are just going to rewrite exact. And then rewrite opposite inequality, negative after. And we need to figure out, this is grade or, so it's an or situation. Okay, so I'm going to multiply both sides by 5. I get 4x minus 1 is greater than or equal to 30. Add 1 to both sides. 4x is greater than or equal to 31. Divide by 4, divide by 4. Get x is greater than or equal to 31 over 4 does not simplify. So again, times 5 times 5. Get 4x minus 1 is less than or equal to negative 30. Plus 1 plus 1. I get 4x is less than or equal to negative 29. Divide by 4, divide by 4. I get x is less than or equal to negative 29 over 4. Okay. I want you to realize the negative is obviously smaller. Okay. So x is greater or equal to 31 over 4. And x is less than or equal to. So all of those are solutions. So it goes from negative infinity to negative 29 over 4. Oops, sorry, that's a bracket. Or 31 over 4 to infinity. Okay, now on this next one, this one does not have my absolute value alone. So I need to get it alone, and by doing that, I need to add 3 to both sides first. And I get the absolute value of 7x minus 7 is greater than negative 2. So again, we have a negative, so we stop. Okay, my absolute value is alone, so I am allowed to look at that now. Okay, so this tells me that my positive number is greater than a negative 2, which is true. So it's all real numbers. Okay. Okay, number 10, if you notice we do not have our absolute value by itself, so we need to get it by itself. So I'm going to subtract 5 from both sides, and I get negative 3 is the absolute value, or times the absolute value of x plus 2. It's less than negative 9. Now I divide by negative 3, divide by negative 3, and I get the absolute value of x plus 2 is greater than, because I divided both sides by a negative, I have to flip 3. Okay, we needed our absolute value to be alone, and now it is. So now I can separate and solve. So x plus 2 is greater than 3. X plus 2 is less than negative 3. Flip your symbol opposite after. Okay, so when I solve, I'm going to do minus 2, and I get x is greater than 1. Minus 2, I get x is less than negative 5. So on my number line, I have negative 5 and 1. Now, we didn't even look. This is, we wait till our symbol's by itself. It's greater. Okay. So x is greater than 1. And, oh, not equal to, sorry. That's a parentheses. And x is less than negative 5. Okay. This is an or problem, so it goes negative infinity to negative 5, both with parentheses, or 1 to positive infinity. Okay, we have another one. Our absolute value is not alone. This one we just have to divide by negative 2. When we divide by a negative, we flip our symbol, and this gives us positive 4. So we can separate and solve now that our absolute value is alone. Now, I also want you to realize this is a less than, so it's an and situation. So I get x plus 4 is less than 4. X plus 4 is greater than negative 4. Opposite sign, negative after. So minus 4, I get x equal, oh, not equal, sorry, is less than 0. Minus 4, x is greater than negative 8. So this is an and, so it has to satisfy both. I have negative 8 and 0. X is less than 0. X is greater than negative 8. neither are equal to, and remember your solution is where they overlap because it's and. So it goes from -8 to 0. Okay, this one, my absolute value is already alone. Okay, it's okay. We are going to flip it. So we're going to just move that equals 5 to the other side. So we're going to write it exact. 4 minus x over 5 equals 5. 4 minus x over 5 equals -5. And we're going to solve. These are equal signs, so no graphing. So we're going to subtract 4 from both sides. Get -x over 5 equals 1. I don't know why that took me so long. Okay, now to get rid of the negative and the 5, we're going to multiply, because that's divide, by a -5, because two negatives make a positive, and it cancels the 5. But when I'm, oh, well, this is times -5, so we get x equals -5. Okay, so on this side, -4 minus 4, -x over 5 equals -9, times -5 times -5, and I get x equals, what is that, 45? Positive, because two negatives make a positive. So we get -5 comma 45. Okay, here our absolute value is already alone, but we have a negative, so we stop. Okay, is a positive number greater than a -4? Yes, this is true, so all real numbers. Three more. Okay, our absolute value is alone on the last three. Okay, so I'm just going to go ahead and highlight all of them so we see that. They're already alone. We don't have to do anything. Okay, so on this one, we're going to separate 3 minus x over 9 is greater than 2. There's my first equation. It's exact without the bars. Then I have 3 minus x over 9. Flip my symbol negative after. Okay, and we need to pay attention to our sign. This is greater. So this is going to be an or problem. So -3 minus 3, I get x over, I'm going to put that negative on the bottom, is greater than, that gives me 2 minus 3 is -1. Now remember, the opposite of dividing by a -9 is multiplying by a -9. So I'm going to multiply both sides by a -9, and when you multiply both sides by a negative, you flip your symbol. So we get x is less than +9. So we'll do that again, -3 minus 3, x over -9 is less than -5 times -9 times -9, flip your symbol, x is greater than 45. Positive, because two negatives makes a positive. So if you notice, this is the same math, almost, as the one above. Well, at least, I don't know what I'm saying, don't look at me. I was just seeing the 45s and I got confused. Okay, so, but what I was saying, yeah, it is the same math. It's the same process, except it's an inequality. So we have 9 and 45. Now x is less than 9. It's not equal to, x is greater than 45. So we go from -infinity to 9, or 45 to +infinity. Okay, here we have an equal sign, so we're going to write it exact. And then we're going to write it equals to opposite. So -8. And we're going to solve. So we're going to subtract 3. Get -x over 5 equals 5. Now I want you to realize if I multiply this by a -5, it cancels the negative and the 5. Get x equals -25. So -3 minus 3, get -x over 5 equals 8, 9, 10, 11. times -5 times -5. That cancels that and that. I get x equals positive 55. Last one. Okay. I don't know why I drew number line first. I need to rewrite it. So my absolute values alone, so we write it exact, and then flip your symbol opposite. So this is a great or problem. I have -15 and 15. X is greater than 15. X is less than -15. So we get -infinity to -15, or 15 to infinity. Yay! If you have any questions, let me know. I'm here for you. Oh, you can't even see my answer. If you need to, pause it as you go, okay? I know I went kind of quick, but you can pause as you need.